This optimization problem is special and interesting. I gave you a perimeter 200. I am asking you to determine x and y to maximize the area. So normally you set up a primary function and a secondary function, and then you plug in the secondary to primary, and then you take the derivative, you set that equals to 0, and then you get one or two critical numbers, and then either one of them gives you a maximum, right? The reason I said that this problem is special because you are going to get one critical number, and that critical number actually gives you a minimum. So the problem asks for a maximum, but you will do all the math to get a minimum. I will show you how to deal with that, and also you will have to buckle up for some crazy algebra, some plug-in, and then some derivative. Okay, let's get started. So the first question I'm asking is, hey, tell me the perimeter of this figure. So the perimeter doesn't include the dashed line. So what is the perimeter of a semicircle or a circle? The perimeter of a circle is pi times the measurement of the diameter, right? So for the bigger semicircle, what is the diameter? The diameter is x. So we will be using pi x, right? So pi x for the bigger circle. Do we need to divide it by 2? The answer is no. So we have, although we have semicircle, but we have a pair of semicircles. So it is not necessary to divide them by 2. And then for the y, that is pi x plus pi y. And then how about the area? So for the area, we will be using the area of the rectangle plus the big semicircle plus the small semicircle. So what is the area of the rectangle in the middle? That is x times y. And then how about the area of the smaller semicircle or the smaller circle? So that will be, we can treat that as one circle because we have two pieces. So the area of a circle is pi r squared. So that will be pi times, let's do the bigger circle first. So that will be pi times the radius is half of x, and then square. So this is the rectangle, and then this is the bigger circle, and then we also need to take care of the smaller circle, which is pi times 1/2 y squared. So pi r squared, that gives you the smaller circle. Okay, so I'm asking you to tell me what is y and what is x to maximize the area. The given is the perimeter, which is equals to 200, and then forget about the unit. So what is your secondary? What is your secondary function? So your secondary function is, so secondary function, we have a perimeter equals to, because secondary is what is given, so pi x plus pi y, and then the primary, don't worry about the primary. The primary is area equals to some function, but we know that the area, take a look at the area I just wrote, there is x and there is y, right? So I am going to put the y in terms of x, so I'm going to do some work for the secondary. So first of all, 200 subtract pi x equals to pi y, and then we divide both sides by pi. So we have y equals to 200 minus pi x divided by pi, and then we will plug this into the primary. Okay, let's write down the primary. So primary function, which is the area. So the area, we got the area, so which is the area we got above, and then we will change all the y to x. So instead of writing a, I'm going to write a of x, that is equals to x times y, right? So the y is 200 minus pi x divided by pi, and then plus pi, and then 1/2 x squared. Okay, so let's just write 1/2 x squared, and then plus pi, and then 1/2 times pi. I am going to change that to okay, first of all, the 1/2, if I square that, I will get a 4, right? So I will just get a pi over 4. I decide to write like that. So pi over 4, I square the 2 out, and then the y square, I will just do the plug in and then square. So that is 200 minus pi x divided by pi, and then let's make this clear. I plug in the pi to this position, and this position. So if you compare the lines for the area, so the one right here and then right here, you can see that I just plug in the pi. And then how do I get the pi over 4? I square the 1/2 and then put the 4 underneath the pi. All right, so now this is in terms of one variable x. Okay, let's clean this up a little bit and then we will move on to the derivative. So we have a of x equals to, let's take the, let's distribute the x. So we have 200 over pi times x and then minus the pi got cancelled and then we have an x squared. Again, we are going to do a long function for the primary and also for the derivative. You have to be very patient in this problem. So we have 1 over 4 and then pi x squared. And then the other one, I will just, you know what? I will just keep it as it is. So I will just do a pi over 4 and then inside I will do a 200 divided by pi minus pi x divided by pi, which is just an x, and then I square that. So when I take the derivative, I won't be thinking about having a quotient rule inside the denominator. Okay, now the primary is done. Let's get to the derivative. So we have a prime of x that is equals to 200 divided by pi, simple, and then minus 2x, simple, and then plus bring the 2 down, 1/2 pi x, also simple, and then the other one, pi over 4 is a constant. I will just bring the 2 down, and then we have 200 over pi minus x, and then square, and then by chain rule, I take the derivative of the inside. I have 0 minus 1. And then we have to clean this up for sure. So we have a prime of x, 200 divided by pi minus 2x and then plus 1/2 pi x. And then this one, the 2 and the pi. So first of all, I can bring a minus up. So that becomes minus pi over 2. Oh, why do I still have a 2 up there? The 2 is... I brought it down, so the 2 is supposed to be gone. I'm sure everybody realized that is a mistake. And then what else? I have 1/2 pi and then 200 divided by pi minus x. I don't recommend doing a big jump because if you mess up one tiny little detail, you will have to do this all over again, and it is very hard to find a mistake. Trust me. And then minus 2x plus 1/2 pi x, and then minus, this becomes 100, right? And then minus, that will be a plus, and then we have a pi over 2x. Okay, what else can be simplified? So we know that these two can be simplified, so these two can be simplified. That will be a half plus a half. So overall, we will get a prime of x equals to 200 over pi and then minus 2x, and then half plus half is a 1, so pi x, and then minus 100. So finally this is fully cleaned up, and then we have to set that equals to 0 because we are looking for a critical number at the horizontal tangent, and then to prove a maximum we need an increasing horizontal and then decreasing. Okay, let's solve for x then. So to solve for x, I'm going to move all the x to the other side. So we have 200 over pi minus 100 equals to 2x minus pi x. Be patient, we are getting close. So and then we have 200 over pi minus 100 equals to, take the x out, we have 2 minus pi, and then as a result we have x equals to 200 over pi minus 100 divided by 2 minus pi. This is my critical number. So this is my critical number, or you can call this a critical value. Either one is fine. And then this one, to make my testing more convenient, I approximate that a little bit. So that is approximately equals to, oh, when you approximate, there is a pi, should be a pi key in your calculator. Don't use 3.14. Use the pi key, because 3.14 is an approximation. So that is approximately equals to 31.83. All right, and then when x is equals to that, So when x is equals to that, you will find out that y is equals to the same value. So let me show my web to get there. So y equals to that. So in order to get y, do you see that there is a y right over here? Do you see that? Here. Follow my cursor. So y equals to 200 minus pi x divided by pi, right? So when x is equals to that, y is equals to 200 minus pi times 31.83 and then divided by pi, so you will get 31.83 as well. So if this is if that critical number gives you a maximum, then that is the measurement of x and the measurement of y, if that gives you the maximum. Okay, and then what else do we need? We also need to consider the 2n, right? So we also need to consider the 2n. So now we have this pair right over here, and then we can do a pause and then take a look at the other one. Actually, you know what? Since we are at the derivative, I will just move on first. I will get back to the 2n. So for this one, I am not going to do a sign chart, do the test interval, and then do the test value. I will use another method. That method is called the second derivative test. So second derivative test. What is second derivative test? So we get the second derivative, a double prime. So look at this line right over here. So take the double prime, we have a -2 plus x plus pi, right? So we have a -2 plus pi. So that is equals to -2 plus pi. This is much faster. -2 plus pi is always greater than 0. As a result, a double prime, you plug that in, 31.83, that is always greater than 0. That tells me that this is a concave up. Second derivative greater than 0, concave up. As a result, when x equals to 31.83, we have a minimum. And this is where people get stuck, because the problem is asking for a maximum. You did all the work to get a minimum, so people get panicked and then they think that, okay, I did something wrong. Did you do something wrong? The answer is no. So that's why I picked this problem for discussion. Okay, so now we need this, so don't erase that. So let's take care of the 2n. So for the 2n, first I'm going to change to a different color, and then I'm going to move back up, and then we take care of the 2n right here. So this one we are talking about measurement, right? So the smallest possible x is x equals to 0. So let's talk about this. When x is equals to 0, y is equals to 200 minus pi 0 divided by pi. So y is equals to 200 over pi. That is approximately equals to 63.66. And then when y is equals to 0, let's change that to a different color. So when y is equals to 0, so we have 0 equals to 200 minus pi x divided by pi. When you solve for x, this one you also get x equals to 63.66. So the discussion is, if you want to other than the measurement we got, the 31.33, you can just let x equals to 0 and then just focus on y. So if you let x equals to 0, the semicircle on top and bottom is gone. Take a look at the graph. If x is equals to 0, the semicircle on top and bottom is gone. Then we will just keep the rectangle and the two smaller semicircle. If we let y equals to 0 and the two semicircle on the side will be gone, then we will be keeping the 2x plus the rectangle. All right. Okay. Now, so this is one of the possible pair to test. Okay. So now, what we are going to do next is we are going to test every possible pair. X equals to 0, y equals to this, y equals to 0, x equals to this, and also x equals to this and y equals to that. And where is my area? My area is right over here, right? So I am going to copy this, and then I'm going to paste this over here. I'm going to paste this over here because this is what we got at the very beginning. Of course, I will erase the extra stuff. So when x is equals to 0 and y is equals to 0. So when x, should I follow the color code? Yes, let's follow the color code. So when x is equals to 0 and then y is equals to 63.66. So we have area equals to 0 times 63.66 and then plus pi 1/2 times 63.66 and then plus pi and then 1/2 63.66 square. That one gives you 3182.90. And then the other one, when x is equals to 63.66, y equals to 0, the area, if you do the plugging carefully, that one we also get 3182.90. And then what else? And then what else? 31.83 right over here, right? So the 31.83. So what happened when x is equals and x and y? So x equals to y equals to 31.83. So if you do the plug in the area, so plug that into x and y, so that one gives you approximately 2604.60. So where is the minimum and where is the maximum? So this is the area. These are the area. So which one is min and which one is max? Actually, the second derivative test is right. So this actually gives me a minimum. The yellow actually gives me a minimum. The question asks for a maximum, right? If you do all the work, you reach to a minimum, you get panic, especially in the middle of the test. So you're right, that actually gives me a minimum, but what else you need to focus on is the 2n, when x is 0 or y equals to 0. So either measurement gives me a maximum area. So that tells me if you want to maximize the area, you either let x equals to 0 or y equals to 0. So the conclusion is to get maximum area, either x equals to 0 or y equals to 0. That is the conclusion. We let the measurement be everything else. So you go to what y equals to, you let y equals to 0, you get the whatever x is, that gives you the maximum area, or you let x equals to 0. All right, so that is the end of this problem. If you like the problem, you like the way I explain it, give me a like, share, and subscribe. I truly appreciate your help, and I will catch you all in the next problem. Signing out.